Welcome to today's paper reading. Today's paper is titled, Beyond Preferences in AI Alignment. This paper was published on the AR14 preprint by Zhi-Xuan and colleagues from MIT, UC Berkeley, University College London, and University of Cambridge. The preferentist approach to AI alignment assumes that preferences adequately represent human values, that human rationality can be understood through preference satisfaction, and that AI systems should align with human preferences to ensure safety and value compliance. However, this paper challenges these assumptions, highlighting the limitations of rational choice theory and how preferences fail to fully capture the semantic richness of human values. Additionally, utility representations overlook the potential incommensurability of these values. The paper argues for an alternative approach where AI systems align with normative standards appropriate to their social roles, negotiated and agreed upon by all relevant stakeholders. This reframing aims to promote mutual benefit and limit harm despite diverse human values. The introduction of this paper highlights the growing concern over AI systems that do not align with human values. This concern stems from both the existential risks posed by powerful autonomous systems and the broader dangers and opportunities presented by transformative AI technologies. To address these challenges, AI alignment has emerged as a field focused on ensuring AI systems act reliably in accordance with human values. However, the concept of human values is imprecise, and aligning AI with human preferences faces numerous technical and philosophical challenges. This paper argues for the need to move beyond preference-based formulations of AI alignment, proposing alternative approaches that better account for human cognition and values. Table 1 outlines the four theses characterizing the preferentist approach to AI alignment. The first thesis posits that human behavior is well modeled as the maximization of a utility function representing preferences. The second thesis asserts that rational agency is characterized by the maximization of expected utility, and AI systems should adhere to this normative standard. The third thesis suggests that for an AI system to be aligned with a single human, it should act to maximize that individual's preferences. Each of these theses is accompanied by a discussion of their limitations and potential alternatives, providing a comprehensive view of the current state and future directions in AI alignment research. The central tenet of rational choice theory assumes that humans act to maximize their preferences, represented by utility functions. However, this model has significant limitations. It fails to account for systematic deviations from optimality, such as cognitive biases and resource constraints. Additionally, it struggles with modeling the incompleteness of human preferences. To address these issues, alternatives like resource rationality, temporal logics, and vector-valued utilities are proposed. Resource rationality posits that human behavior can be understood as the rational use of limited computational resources, while temporal logics and vector-valued utilities offer more expressive frameworks for capturing the complexity of human preferences. Table 2 outlines the assumptions, limitations, and alternatives to rational choice theory in modeling human preferences and decision-making. It highlights resource rationality as a framework that can unify various cognitive biases, suggesting that these biases can be understood as rational use of limited computational resources. Additionally, it mentions temporal logics and reward machines as methods to better capture time-extended preferences, and vector or interval-valued utilities and conditional preference networks, CPNets, as ways to model preference incompleteness. These alternatives aim to provide more accurate and comprehensive representations of human decision processes. Expected utility theory (EUT) assumes that rational agents must have complete preferences and maximize expected utility. However, these assumptions face significant limitations. EU maximization is computationally intractable and provides limited insights into actual AI behavior. Instead, alternative analytical lenses such as mechanistic, economic, and resource rational analyses offer more practical approaches to understanding and aligning advanced AI systems. These alternatives focus on specific AI paradigms, economic competitiveness, and computational feasibility, respectively, providing a more nuanced view of rationality beyond EUT. Table 3 outlines the assumptions, limitations, and potential alternatives to expected utility theory (EUT) as a normative standard for rationality and reasoning. The table highlights that while EUT assumes that sufficiently rational or intelligent agents will act to maximize their expected utility, this assumption faces limitations such as the requirement of preference completeness and the computational intractability of EU maximization. It suggests that alternative analytical lenses, such as mechanistic analyses grounded in AI paradigms, economic or evolutionary analyses, and resource-rational analyses, could provide more feasible and informative frameworks for understanding and aligning advanced AI systems. The chapter discusses the assumptions, limitations, and alternatives to single-principle AI alignment by matching and optimizing an individual's preferences. The assumptions include the commensurability of values within and across contexts, implying that ideal behavior in one context applies to others, and the static and asocial nature of preferences. The limitations highlighted are the use of scalar reward optimization, which is limited to bounded, task-specific AI systems, and the dynamic nature of preferences that change via learning, reflection, and value transformation. Additionally, the normative unacceptability of certain individual preferences is noted. The alternatives proposed involve using context-sensitive rewards for AI that cannot optimize across contexts, aligning with informed, post-reflective preferences, and aligning with task and role-specific normative criteria or the normative ideal of a good assistant. Table 4 highlights the assumptions, limitations, and alternatives to aligning AI systems with an individual's preferences. It points out that current methods assume values are commensurable and preferences are static and asocial, which may not reflect the dynamic and socially influenced nature of human preferences. The table suggests alternatives such as aligning with informed preferences, role-specific normative criteria, and considering the normative ideals of a good assistant to address these limitations. Table 5 highlights the assumptions, limitations, and alternatives to multi-principle AI alignment by matching and optimizing aggregate human preferences. It points out that naively aggregating elicited preference data can conflate task-specific preferences with overall welfare preferences, leading to exclusionary and potentially harmful outcomes. The table suggests that instead of uniform aggregation, task or role-specific aggregation of normative judgments could be more appropriate. It also proposes prioritarian, egalitarian, or contractualist approaches to preference elicitation and aggregation as alternatives to utilitarian methods. The chapter discusses the limitations of preference aggregation in multi-principle AI alignment. While preference aggregation is theoretically supported by utilitarian ethics and practically applied in methods like RLHF, it faces significant challenges. These include misinterpretation, political infeasibility, and foundational issues with utility theory. As alternatives, the chapter proposes non-utilitarian aggregation methods that consider veto rights and prioritize affected groups. It also introduces contractualist alignment, which aligns AI with negotiated normative standards rather than aggregate preferences. This approach is more politically feasible and practical, reducing conflict and computational costs while enabling pluralistic AI use. The chapter concludes by emphasizing the need for both technical and social-political advancements to achieve fair and impartial AI alignment. In this conclusion, the authors challenge the centrality of preferences in AI alignment. They argue that preferences, while constructed from our values, norms, and reasons, should serve as proxies for our values rather than be the direct targets of alignment. The future of AI alignment should move towards richer models of human decision-making that include how we evaluate and act upon our values in boundedly rational ways. This approach would explore the normativity of our preferences and values, distinguishing between different types of preferences and identifying which are operative in specific decisions. Additionally, it would embrace the normative complexity of defining AI's social roles and move towards a more pluralistic understanding of alignment, beyond just aggregate preferences. Thank you for watching.